What's up, everybody? Here's the deal. Students lose easy points on Unit 2 every single year because they blur ideas that sound the same but aren't. Today, we fix that. Sensation and perception, how memory actually works, thinking, and intelligence. The whole cognition unit, locked in. Stick with me to the very end, and I'll show you the single fastest way to lock all of this in before exam day. Grab a pen, and let's go. Start with the two words students always mix up. Sensation is your sense organs detecting raw physical energy from the world. Perception is your brain organizing and interpreting that information so it actually means something. The College Board wants you to know the bridge between them. Converting physical energy, like light or sound, into neural signals your brain can read is called transduction. And you process information two ways. Bottom-up processing starts with the raw sensory data and builds up. Top-down processing uses your existing knowledge and expectations to interpret what you sense. Lock those two in. Now the limits of your senses. The absolute threshold is the minimum stimulation you need to detect something 50% of the time. The difference threshold, also called the just noticeable difference, is the smallest change you can detect between two stimuli. Here's a key one. Weber's law says that to notice a difference, two stimuli must differ by a constant percentage, not a constant amount. Signal detection theory explains why we sometimes catch faint stimuli and sometimes miss them, depending on our expectations and alertness. And through sensory adaptation, you stop noticing a constant stimulus, like how you forget the feeling of your socks. So how does your brain organize all of that? Gestalt psychologists showed that we naturally group things into wholes, using principles like proximity, similarity, and closure, where we fill in the gaps to see a complete object. To see in 3 dimensions, you use depth cues. Binocular cues need both eyes, like retinal disparity, the slight difference between your two eyes' images. Monocular cues need just one eye, like relative size and linear perspective. And thanks to perceptual constancy, you still recognize an object as the same size, shape, and color, even when the image on your retina changes. That's a classic exam set. Now the big one, memory. The classic 3-stage model goes like this. First, sensory memory holds a split-second snapshot of everything your senses take in. Then, if you pay attention, it moves into short-term or working memory, which holds about 7 items, plus or minus 2, for around 20 seconds. Working memory is where you actively think about and manipulate information. Finally, through encoding, information passes into long-term memory, which is essentially unlimited capacity and can last a lifetime. Lock in this chain, because attention and rehearsal are what move information from one stage to the next. Getting information into long-term memory is called encoding. Some of it is automatic, like remembering where you sat today, and some takes effort, like studying these terms. Here's how you encode smarter. Chunking groups information into meaningful units, which is why a phone number is split into chunks. Mnemonic devices use memory tricks like acronyms. The spacing effect shows that studying spread out over time beats cramming. And levels of processing says deep processing, focusing on meaning, creates stronger memories than shallow processing, like just memorizing how a word looks. Apply that tonight. Long-term memory isn't just one thing. Explicit, or declarative, memories are the facts and events you can consciously describe, and these split into episodic memory, your personal experiences, and semantic memory, your general knowledge. Implicit, or non-declarative, memories are the ones you can't easily put into words, like procedural memory, the skills of riding a bike. And here's the part the exam loves. Different brain parts handle different memories. The hippocampus helps form new explicit memories, the cerebellum stores implicit and procedural ones, and the amygdala burns in emotional memories. Getting a memory back out is retrieval, and it comes in 2 flavors. Recall means producing information from scratch, like a fill-in-the-blank question. Recognition means just identifying it, like multiple choice, which is exactly why recognition feels easier. Retrieval cues help you find a memory, and priming is when one thing unconsciously triggers another. Context-dependent memory means you remember better in the same place you learned. State-dependent memory means you remember better in the same physical or emotional state. And the serial position effect, you best remember the first items called primacy and the last items called recency in a list. So why do we forget? Hermann Ebbinghaus mapped the forgetting curve, showing that we forget most of what we learn very quickly, then it levels off. Sometimes it's simple encoding failure. The information never got in. Other times it's interference. Proactive interference is when old information blocks new. And retroactive interference is when new information blocks the old. And here's the kicker. Memory is not a perfect recording. The misinformation effect shows that misleading information can corrupt a memory, because every time you recall something, you reconstruct it and can change it. Now, thinking. You organize the world using concepts, mental categories, and prototypes. Your best example of a category. To solve problems, an algorithm is a step-by-step method that guarantees a solution but is slow, while a heuristic is a mental shortcut that's fast but error-prone. Now watch out for these biases because they show up constantly. The availability heuristic judges how likely something is by how easily examples come to mind. The representativeness heuristic judges by how well something matches a stereotype. Confirmation bias is seeking out only information that supports what you already believe. And framing shows that how a choice is worded changes your decision. Finally, intelligence. Charles Spearman argued for a single general intelligence, called G. But Howard Gardner proposed multiple intelligences, and Robert Sternberg proposed 3 types: analytical, creative, and practical. To measure it, Alfred Binet created the first intelligence test, later refined into the Stanford Binet, and David Wexler built the most common test used today. Lock in the 3 test must-haves. A good test is standardized, given the same way to everyone, reliable, giving consistent results, and valid, actually measuring what it claims to. And IQ scores fall along a normal curve, where most people score near the average of 100. And that is Unit 2, Cognition. Sensation and perception, thresholds, the memory model, encoding, retrieval, forgetting, thinking, and intelligence. You just covered all of it. But here's the truth. Watching is not the same as knowing. So here's that fastest way to lock it in. Head over to AIM5 and practice Unit 2 for free with instant feedback that shows you exactly where the points are. The link is right below. Now go get that 5, and I'll see you in Unit 3.